Hi everyone, and good morning, good afternoon, good evening, depending on where you are joining this from today. Welcome to Harper's webinar. Today is all about vector indexing, logging, and performance. So we're going to be talking about what's new in Harper 4.6. My name is Nenne Nwodo, and I am a DevRel consultant at Harper. And with me is Jaxon. Jaxon, would you introduce yourself?
Hi there. My name is Jaxon Repp. I am the field CTO for Harper.
It's nice to be here. If you are joining this, wherever you are joining this from, if you can in the comments, please, let us know where you're joining this from, where you are in the world. It would be nice to know or to see how many people are represented here. So rep your country, rep your city, let us know. But I'm excited to be here today. It's exciting to be having this conversation. And before we start, one thing I would like to say though is that this is a technical discussion. We're talking about Harper 4.6 and all the things that you can now do with it as a developer, what makes it better for you. It's not a sales pitch, it's technical. And so let's get ready to talk about technology for the next hour. And so this is very exciting for me. The first question that I have for Jackson, right, and it's just sort of a way for us to kickstart this conversation, is we've seen the industry change literally before our eyes over the last couple of years. And a lot of things have changed, with technology, community, and search as well is something that is changing. How do you really think that search has changed in the last 18 months compared to what it was before?
Well, I think every discussion begins and ends with performance. So it always comes down to how quickly can we get a user the information that they want. Um, the quickest way for that has changed form over years. So from simple SQL queries where I might be, looking at a billion rows of data and trying to find something that has a single word in it and deploying a SQL query with, select where percentage sign like percentage sign some value and massively non-performant search, but it was the best way we could do it. And then we began to have more constructive, interesting ways to index things. And things like full text search, where I was capable of creating, groups and globs. But now, obviously, AI has entered the picture, and the idea of vector embeddings to create a kind of a picture in a very easily navigable matrix that computers are much better at than us to determine what is actually closer to the thing you're looking for than anything else. So I think as as performance has evolved, so too then has search, because everything continues to get faster, but the data keeps getting larger. So we need more advanced strategies for finding the right data, finding that needle in that haystack.
I think that as the data is getting larger, I think there's also a bit of human behavior evolving a lot, right? Now, for me, I feel like at this point now, everything is a search engine. Like before, you think about search engines that you see the traditional search engines with the Googles and the Bings and the things. And now, literally, people are searching for things on YouTube. They're searching for things on TikTok. They're searching for things in
Mhm.
ChatGPT. They're searching for things across different places using natural language. And so, as a result of that, the model in which search is powered has to evolve as well to accommodate that. So as much I believe that as much as the data is growing and we need to accommodate that, because we can still decide to select from percentage like percentage if something, right? But there's also and even if it will be slower to give us back the results, it will give us back something. But now someone might be searching for, oh, I want I want to look for, I'm going to use this as an example because I'm currently in the phase of looking for photographers for a shoot that I'm trying to do because my birthday is coming up. And so I'm like, okay, I want to look for photographers in this area for a photo shoot. Right. And so if the data shows photographer photo shoots London or Lagos or whatever, then it can point me to what I'm looking for. But it might not necessarily be the case. It might be that from the data, it is inferred that this is a shoot and I get that result. And that might be actually the result that I'm looking for. So, in a way, as well, I think user behavior has changed the way some things are, which now brings me to something. Because when we talk about the evolution of search, we hear semantic search, we hear vector search. Which is which, and what's the difference?
Well, semantic search is the idea that I would find things based on their meaning. So, what that meaning is, how I codify that meaning, what is similarity in the grand scheme of text versus an image versus video versus a JSON document. So, determining what similarity is, it's easier when you're using traditional, like a NoSQL search, right? It's a JSON object where I have conditions and it must look like this. But when you've got a large corpus of text, the number of conditions is equal to the number of words. And that's not navigable for human beings. So if we look at semantic search, the key is determining what that meaning and what likeness actually is. So one of the ways we can do that is with vector search. There are lots of other ways. Semantic search could combine something like a vector search, and we can dive into what that is, along with traditional attribute-based searches, where yes, it has to be close to this search term, but also this other value in this database must be blue. So the idea that we want to find some sort of semantic reasoning, semantic agreeable format of the truth, and then take an inbound parameter and say, what's close to this, however we choose to define it. So I would say vector search is a subset, a method within which we can achieve good semantic search, defining that meaning and then locating things that mean something approximately close to it.
Okay, so semantic search is more like the parent, right? So vector search is a way that we can achieve semantic search. One of the things that I hear when I think about, okay, how to do vector indexing, one thing that consistently pops up is something called HNSW. So
Yes.
why is that over other vector indexing approaches, and what exactly is HNSW?
Hierarchical navigable small world algorithm is a calculation as to what any given set of numbered matrices, which is ultimately what we boil down a large record into when we are searching it. So think lots of 1 comma 2 comma 3 comma 4, or binary numbers with floats, and sorry, floats, in a comma delimited multidimensional matrix. How do I, as a human, make sense of that? I absolutely can't. But I want to look at that and say, it is close to what I want to do. And the algorithm we use to calculate the distance between the inbound search term and all of the records in my database is there are varied approaches of them. But ultimately, what we're trying to find is the nearest neighbor. And hierarchical navigable small world is a very good trade off between dead accuracy, like the most accurate, the closest thing, and performance. Because obviously, I could do really in depth calculations and compare every single record. But if I organize the indexes correctly, as I find one, I will find its nearest neighbors. And so I can begin to build a pool of records as I work through a tree after finding one that's closer than the next, and then ultimately building that corpus of items I want to return. It doesn't necessarily guarantee that that my closeness calculation is going to be exact, but if I were to do that, then the search term, takes a very long time to identify exactly what those exact vector similarities are. So HNSW, hierarchical navigable small world, is a combination of those two. It's a good compromise between performance and accuracy.
Okay. Are there like other vector indexing approaches beyond HNSW? And Do people really use them as much as they use this one?
Yes, there are. There are many. There are myriad. In the same way that I like the way that I make an ice cream sundae and you make an ice cream sundae differently, and all the ice cream sundaes are delicious. Mine might be faster because I want to eat the ice cream sundae right away, and yours might be slower. But at the end of the day, this is usually the most popular one. It's the one where everybody starts. There are much more specialized ANN, like approximate nearest neighbor algorithms. This is the one that has a very, very established library, suite of libraries. So it's probably where everybody dips their toe in. Um, if you are deploying a different model, it is usually because the data itself that you are attempting to find nearest neighbors is either more complex, but allows you to specialize more and deploy a more specialized model for creating those calculations and determining what those nearest neighbors are. So this is a good general purpose algorithm. It is extraordinarily effective, we have found, with our customers. So this is the one that we launched our vector search with. But as with all things Harper, we build these things in a modular way. So in addition to the ability to do vector search, we focused on a lot of the other configurability options that you find. So we offer the ability to generate embeddings using like an open AI. Or you can use an open source Olama, and you can even have that be local within the instance. So we wanted to accommodate some of the bigger choices, which is the accuracy of, say, a paid model like OpenAI versus the somewhat lower generally accuracy or perceived accuracy of a local model like an open source Olama. Um, and then when customers come back to us and say, you know what, HNSW isn't really doing for me. I want to layer in my own algorithm because my data is highly specialized and my searches need to be highly optimized. And then we add that configurability. But when introducing our developer population to a new concept, we want to kind of make it as simple as the rest of our product. So we kind of abstract away a lot and go with the easiest way to get you up and running, to find joy, and to ultimately deliver results before we begin to specialize.
Okay, that's fantastic. So, one thing that I would say for the audience is that you've heard it, and I'm just going to reiterate the fact that we have the capability right now for, you know, vector search, vector indexing, and we've released it in Harper 4.6. So you can check it out, play with it, see what works for you. And well, I would like to see what you'll be building with it because there are a couple use cases that I'm going to be talking about in a second, right? But like beyond even beyond that, right? I would also want to share that you could check out the documentation, right? So if you go to the Harper documentation, we've released 4.6, like I said, and we've released this as part of 4.6. And there's also a blog post that was written a week ago about vector search as well. You can check it out just so that you understand what it is, how it works, and what you can do with it. So there are a bunch of things that we can do with it, and I would like Jaxon to tell us. But before that, I could also state a couple things. One very common one that jumps at me is e-commerce recommendations. For example, you're trying to shop at a website, and then you literally just search for blue skirts, right? Normally, you would probably have to go and search for skirts and then have the company rather have the backend system do like a in a regular SQL fashion select skirts um from all the records. And if somehow they take products like properties of their products, you can now maybe on the sidebar you might see filter by color and then you filter blue and then all the blue skirts show up. But nowadays, you can literally just search for blue skirts and you get to see blue skirts and other maybe kinds of blue outfits come up as well. And that's just to show how dynamic searching has become as well. You can search for code similarities. You can do real time video search as you're watching like videos to know. Sometimes people do things like searching the lyrics of the song if they don't remember the song, searching the lyrics of the song on like, or searching what was said in the video and who said it. And that actually gives you the right video at the end of the day. And you're able to do this because of what search has become. So beyond a couple of these use cases, Jaxon, could you tell us more use cases that you think people could use vector search for in this new world?
Sure. I think wherever we used to use something like a full text search, where we created multiple indexes around intelligent words and alternatives of intelligent words, um, we can now abstract away the form of that underlying data. So it's not text anymore. It's literally images, and we can boil those down to a multidimensional matrix that we can then analyze in a vector fashion. It can be every frame of a video to determine, what's in that video, who's in that video, and what might I like to buy. And one of my favorite examples is video services that identify particular actors, and those may be hard coded, but there are other tools where you can go through and say, I want to give this person a recommendation as to what they should watch next. All of their favorite movies have classic cars in them. How do I determine what a classic car is? What is that knowledge base? How do I flag that as an attribute? Because it's not mentioned in the standard metadata that comes with a movie, for example. It is part of content metadata that we can generate when creating an index so that we can search against it. So there may be a model that is trained on identifying classic cars or cars of every specific generation. You run the video through it and it flags the ones that have classic cars. Now, if you've watched a lot of videos that have that flag, I'm going to recommend videos that have that flag for you, and I'm going to be able to, tap into that. And if you don't select that in that recommendation panel right below the movie you're currently watching, then perhaps I will deleverage that when I start to look. Well, maybe it wasn't the classic cars. Maybe it's the chase scene. Maybe it's the era. Maybe it's the outfits that they're wearing. So being able to identify classic cars, great. But when you're talking about recommendations, humans are inherently way more complex than I like classic cars. I mean, there's some people that are like that, but most of us find an aesthetic, which is really hard to capture in an attribute in a database and search for. So what vector search is really good for is identifying within a holistic picture what similarity might look like, and then from the database of other options, finding things that might be close.
That's perfect. Thank you. So now I'm just going to move on into the summary of everything that we've been saying. Basically, is that full text search in traditional SQL databases don't scale. So typically, if you want something nowadays, if you want something more dynamic, you'd have to end up with hybrid architectures. You need your database, you need a search engine, you need to worry about syncing, and that's like different headaches. So I want to ask you actually, what's the worst text search performance problem that you've solved?
Like, it's interesting having started off as a database, now a composable application platform, but we started by building a database and all of the problems that come with deciding that no other of the hundreds of available options, none of those other options are sufficient, and we're going to do it from scratch. Which now, in retrospect, 7, 8 years later, seems foolish. But a lot of the problems we solved weren't around search themselves. It wasn't around, how we store or interface with data. It's the ergonomics around search. How do you make search as easy as Google did when they launched the first search engine? It was a single box, and you type things in, and magic happened. And so, how do we make this massive amount of complexity that we've just described, right? The evolution of how we look for things, and what we look for and what we expect as humans now in terms of results. How do we make that easy? How do we make that feel like it's natural? And then obviously, because we have existing search functions, how do we combine them in a way that feels natural? And ironically, if you look at what we did, we ended up building into our query optimizer, where you search for certain attributes from certain tables. A query optimizer will find which tables are going to whittle down the result set quickly, most quickly? And then when I add a new table in, is I got a lot of records or very few records? How do I most effectively whittle this down so I'm doing the fewest scans of tables and indexes possible? And then you look at vector search where everybody has a value, and to calculate the nearest neighbor may not actually be the most efficient solution. In some cases, we will do the vector search first. In other cases, we will do the attribute level search first, and we'll actually treat the vector search and the results, the distance we find between all of the candidates, as almost a sort. So we can attack it from multiple ways, but all of that we thought should be abstracted away from the user because they just want it to work and they just want it to be fast. So I wouldn't say it was a search performance; it was an ergonomic performance because we could have just simply, slapped this on the side of our existing solution and let everybody run wild, and inevitably we would teach practices that we felt in the long term weren't the best practices and the best interest of our platform, nor in the lives of our users, whose our charter is to make developers' lives easier.
That makes sense. That makes sense. And that's actually really powerful. Thank you so much. So we've been talking about vector search for a bit, but with the release of 4.6, there's a bunch of other stuff that came through as well. One of them I would
Yes.
say is developer focused logging, right? With Harper
Yep.
4.6 now, it traces every HTTP request through the entire stack. So you can see exactly where time is spent. You can see which queries run and how the data flows. And it's easier, like, it helps people that, are looking for all these trails, find those trails faster, debug better and things like that. Can you walk us through how this looks like in practice?
Sure. Absolutely. This is one of the things that if everything around vector search was making it highly usable and highly efficient and abstracting away the complexity of hierarchical, navigable small worlds, which is a mouthful by itself and a ton of complexity goes into it. This was an example of us abstracting as we built this platform, which is a web application, composable performance platform. Um, we abstracted away some of the logs because our workflow says we develop locally, we test locally, we have a console over here, we see them all being spit out, and we debug, and then you send it to production, nothing ever goes wrong, which is never the case. And it's extraordinarily helpful to have access to the entire HTTP lifecycle in the logs, or as much of it and in the form that you want. And we had abstracted a little too far, right? So premature optimization being the root of all evil, in the inimitable words of Donald Knuth, we decided to roll it back and give more visibility and more configurability into those logs. So that includes individual logging settings per component. It's highly configurable, not just what gets logged and when, but the format in which it gets logged, because obviously lots of people have different tools that they use to analyze those logs. Um, as a developer, console logging used to automatically go to the actual files, and when customers or we would deploy something with a console log in there, that could lead to a lot of overflow and excess logging. So we wanted to remove that. And then finally, new logging settings don't necessarily require a restart of the application itself. So that is a big one for some of our customers, are some of the largest companies in the world, some of the largest retailers in the world, selling thousands of products a minute and making hundreds of millions of dollars a day. And if we tell them that we have to drain connections and restart because they want to see more logs, because they're troubleshooting, well, they're troubleshooting. The last thing I want to do is add to their troubles by removing a pool of connected resources in use by customers. So we wanted to make sure that that was as smooth as possible, with the automatic restarts, but also that when they actually did gain access to these, they were in exactly the shape that they wanted, so they could very quickly determine what they were looking at and what action to take next.
So this feature actually makes logging very simple, or simpler than it used to be. And so, in the context of simplicity, there's also something that I want to ask you. 4.6 has introduced a new plugins API. So, can you explain, what that is and how it's different from the extensions that we already know and many people have been building with?
Sure. The extensions, if you're familiar with our application platform as a whole, applications are self-contained pieces of functionality that run. They can export endpoints, they can uh, initiate pub sub connections, they can backfill a cache or load data. Um, Functions that are applications simply run by themselves. Extensions can be used by more than one application. They may be something like a custom auth, right? And the way we had initially envisioned that was they looked a lot like the applications themselves. So whatever methods you wanted to put in there, you could hand back to Harper, and then Harper would export those and make those available inside components. Um, but obviously, that is wildly sporadic in terms of, how do I interact with this thing and how could I possibly simplify it? So we wanted to, based on real customer interactions where we saw them experiencing, the pain of this complexity, we wanted to, again, sometimes we simplify, sometimes we take away the simplifications or the oversimplifications. This was very much a thing of we gave them everything and we realized what they really wanted was something that was much easier to navigate. And so they are dynamically loaded now. They are not necessarily loaded by every component. That's a huge one because obviously not everything needs access to these extensions or plugins, as we now call them. And it registers itself with a single handle component method. So basically, when you turn the system up, the system recognizes this, and now you can dynamically import a single handle component method and leverage that to then take care of whatever functionality needs to be handled. The plugin registers itself and then hands that component method back to your components. And at the end of the day, that is how you interact with it. Much simpler. It further reduces complexity. You know, it's again one of those. Sometimes you peel back the layers, like with logging, and you realize you we made what we thought was sufficient abstraction, but we realized that developer experience wasn't as good as we could possibly make it, and ultimately that is what we're focused on. We are all developers at this company. We all want to make it as easy as possible, but not one bit easier, because there's also a lot of complexity to what we do when we're building things, and we need that visibility. Sometimes we just need it to work though, and so the new plugins API is absolutely a customer driven refinement to our platform, and we make lots of those every day. Um, Within the context of what a perfect world looks like, where nothing is ever truly perfect, we think it's an incredible improvement, and it's a documentation for it is available in the docs. Extensions don't go away. Extensions are still supported. The plan is to eventually deprecate them, but that's a ways off. So you don't have to run out and change over to the plugins API right now, but please explore it, document it in the docs. So much easier, so much more simple, and ultimately it's going to empower people to build way more plugins rather than building that functionality into every component.
That's amazing. Because I was actually going to ask the next question would be that okay, what happens with extensions? What happens with extensions now that we have the plugins API that allows people to build things and makes it simpler than using extensions? But thanks for clarifying that. As we're talking
Sure.
about simplicity, as we're talking about developer experience and enhancements from an AI search point of view, I also want to touch on performance and scale because that's one thing that we haven't talked about at least a bit more intensively as I would like. Um, and so, like, what's your experience with database performance degradation over time, and how does 4.6 make it better?
I think the the majority of performance degradation over time has to do with one of two things: a sheer volume of data that you didn't have before, didn't plan for. one of the reasons we built this platform was we all loved how amazing and simple and easy it was when MongoDB came out and document collection, and I didn't have to declare my columns or data types, and it just seemed to make everything so easy, right? It's web scale. That was the thing. We all said it's web scale, and it totally worked, except the more we began to denormalize data, the more we began to have massive documents associated with every user with embedded, embedded sub collections, so that we could just do a primary key lookup and bring things back. We began to realize the size of data on disk and the ability to update one of those embedded objects when I changed the core data source. A product catalog with, you know, 250 million users that have bought that product. If I change it, in the core product database, and I've actually embedded the product JSON into the user object, well, now I have to go to 250 million locations to update that. And that's a real customer example. So the simplicity of a document store versus kind of how we see data used in the real world and at scale. So that is kind of the first problem. Like, data grows, data changes, how we use it. But then also, I think, to your first point with now vector search, the human expectation of how quickly things come back, how quickly things are updated, how quickly, in the case of that customer where 250 million embedded objects might have to be updated, how quickly I can turn on my console or my computer or my mobile device and see the thing I did on another device, because my record has been updated, not just locally, but in some sort of central data store, and it's very quickly delivered to me everywhere I want to be. So human expectation evolves as well. And so you have to continually improve how you approach scale and how you approach performance. No matter how old your database is, how are humans going to interact with the underlying data? And the way we have chosen to attack that is through horizontal scale. We understand the cost to benefit ratio of horizontal scale to be linear, and as opposed to vertical scale, where we add lots of resources, double the RAM, double the CPUs in my central processing system, that's an exponential cost to capacity ratio, right? 16 gigs of RAM is always more than twice as much as 8 gigs of RAM. So when you get up into the real high numbers with terabytes of RAM, you begin to see real cost implications of trying to run a data-driven application at scale. So we wanted to nail horizontal scale. We wanted to nail efficient data replication. We wanted to improve performance at any scale to the point that it feels as simple as MongoDB did when you first deployed it. But we also accept that all data ultimately is relative. And so relational databases and joins are extremely important. And search performance, competing against embedded, established, battle-tested solutions like Elastic, those are extraordinarily performant solutions that are really good at what they do, but they leverage so much hardware and they are relatively expensive. So we wanted to begin to approach the problem of database degradation over time, performance degradation, by figuring out how we could have unlimited scale and preserve the excellent performance we already have. Because we knew if we grew on top of that data and we just continued to jam more and more data in, we would be chasing efficiency patterns on a monolithic, vertically scaled infrastructure. And we know that that's not the future. So through creative strategies like our dynamic indexing, basically sharding data, intelligent sharding, access-based sharding, and ultimately what our deployment infrastructure looks like. So, currently we deploy clusters, upwards of 100 nodes for customers that are globally distributed. And that can be a bit of a challenge to manage. So without giving too much away, we are working on something that does for infrastructure and deployment, what we believe we did for the application platform itself, and that's to make it extraordinarily composable, to make it, a single click to joy. And that's what we really focus on. Again, developer experience, DevOps experience, really the application experience for those of us who aren't consuming it, but are instead responsible for creating and deploying and maintaining it.
Okay, that makes sense. That makes a lot of sense. So now I'm going to ask you a question still around databases, and I'm going to take you back to that. I'd like you to walk me through what happens under the hood when someone runs a hybrid query. So if they combine vector similarity with traditional SQL filters, how does the query planner decide which index to hit first?
Sure. So there's no secret sauce in this. Everybody does this. It's just that vector search is a little more complex in terms of determining what is the record size. So if I look at somewhere, I'm looking for an attribute equal to blue, color equals blue, size equals large, right? So I need uh, large shirts that are blue. But I want them to look like this one over here. So I have some sort of a vector embedding of a shirt that I like. And what I notice about that, if I'm a model that is trying to capture that and generate an embedding, is that there's copy on it, right? There's a logo or there's some clever saying or whatever it is. So I capture that as part of the attributes. Now I look at that catalog and I say, hey, given that I have indexed the color field and the size field, tell me uh, how many things have blue for color, and if that's 10 million, and tell me how many things have large for size, and if that's 3 million, then I would imagine that things I would first want to filter by the size equals large, because I'm going to immediately reduce everything by that much, and that it reduces the number of entities in the color that I might have to query and look over, and then ultimately sort by that distance. However, when and those were maybe terrible examples because millions of records is never the right answer, but if it were 3 million and 10 million, then there's a very good chance I can eliminate a substantial amount of those by first running through those vector embeddings and doing hierarchical navigable small world calculation to determine where, given an entry point, I can spider out and get together X number of records, because I can also set the limit on the number of records I want. So if I set that limit to lower than, let's say, 3 million, then I could get my data set down to, let's say, 30. Now I can filter those on blue and large, and the smaller data set reigns. And ultimately, there's a little bit of, I'll call it fuzzy logic there, because we don't actually want to query everything, but we do keep some stats in the background to help us make that determination at runtime.
Okay. I'm going to still ask another follow-up search question, but this is more around vector search fully. So we've talked about HNSW, right? But what happens when you need to update or delete vectors? How do you handle index maintenance without blocking reads?
Well, we added dynamic fields in a previous release. So the ability to take inbound data, let's say 2 fields, and based on the attributes that I am putting in, do some sort of a calculation. So we leverage that for vector search in that we generate that. So we can trigger that exact same calculated field on update or on deletion. So if I delete that record, it goes away. If I want to delete or update the attribute, I can simply do a put into the database. I will rerun that calculation based on those new fields. So if there's a field with a product description and that's the thing I'm doing a vector search on, or that and a couple other fields, as soon as I come in, I'm going to recalculate that value. So it maintains up-to-date state as you update that record. Now, if I were to change a configuration in my HNSW algorithm, or swap out algorithms, or swap out language LLMs that were generating these embeddings, then I can simply wipe that data and reissue a command to run through and recalculate all of those after the fact. That does take time, though, and it will limit the ability to do a vector search until those indexes are returned.
Okay. Okay, that makes sense. I think all of this is I would also like to know if there's any questions that you have. If you could, ask us online, would love to answer those questions. We're everywhere on social media. We are on X, we are on LinkedIn, we are on Threads, we are on Blue Sky, we are on Instagram. So if you have any questions at all, you could find us through social media. You could find us through our community as well, through our Slack channel. There are many ways that you could find us. So you can find me and reach out to me as well. Now, I would find that answer for you. I have a couple more questions here, and we're getting to the hour. So I'd like to run through those questions as quickly as I can. But one thing I'd like to say is that we are very social. So if you're enjoying this conversation, if there's anything I've said, if there's anything Jaxon has said that has resonated with you, please put a quote out on social media, tag us, we will repost it. I promise. If there's anything that you'd like us to answer as well, like I said, please hit us with your questions. We're here to give you the right answers and to put you in the right direction so that you can build fantastic stuff using Harper 4.6. So I have like a couple more questions that I'll run through, and so that we could be on time. So the next one is, for customers migrating from multi-system setups, what's the most common performance gotcha that they hit? And is it usually query patterns, data modeling, or something else?
I th- I think for customers migrating into the Harper composable application platform ecosystem, it is kind of a paradigm shift. You are used to having a separation of concerns. We've spent a couple decades now telling people that microservices and separation of concerns is the right way to maintain a stable system at scale, because one component can fail, but you only have to fix that one component. I think when we move to a distributed system paradigm where our users are in lots of places, then we want to be in lots of places close to them. And our real concern is not whether one component fails, because if that component fails, then really the whole pod could be out of commission. So we began to focus on our true concern is that this node can answer questions. So moving away from everything is separate into all of the things are together. There's lots of easily demonstrable benefits to that in terms of security and latency and simplicity and deployment, but it is wrapping your head around kind of what that looks like. And so when we're talking to customers who are beginning to explore this, we say let's start with the biggest pain point you have, whatever that might be. It may be search, it may be a single API endpoint that does a complex federated GraphQL query, it may just be a RESTful endpoint that takes a lot of volume and could stand to benefit from maybe being a little less expensive to serve that volume. And so we identify one thing, we create that endpoint, we work with you to load data in, and we show you how to query it, and then we return that result. So it's not hard to learn, but it is kind of hard to grok if you spent the last several years of your life being taught a different paradigm. Um, that is our primary focus, is education here, because at the end of the day, we know that it's different, but we also have battle tested it, and we know that it works. So we want to help developers realize that there's a different way, and it feels a lot like you're just building locally and running things locally. Everything's easier, and running with local data close to users has such a massive performance advantage, as does collapsing the stack and having all the ingredients in this system reduces latency. We walk into almost every engagement with an in-stack advantage of 40 milliseconds for a round trip for a query of medium complexity. Add to that the fact that we can be close to users, we are saving additional milliseconds just because we're closer to them. And that performance advantage is enough many times to justify investment in that first use case, that first endpoint, that first solution that you build on Harper. And once you realize that the thing that used to take 1,000 lines of code to do now only takes 200, everybody gets the light bulb going off and everybody's like, I get it. It's simplicity without sacrifice. And ultimately, that is what we are all about.
Okay. Okay. Thank you for sharing that. We have a question from the audience. Shout out to Nick for asking this question. So, Nick asked, with an ocean of data needed to be processed in real time, how important are GPUs to the Harper solution?
They are reasonably important if you are doing high speed data ingest and want to calculate the embeddings, generate those embeddings in a performant manner. However, you can use a CPU, and in many ways, we'll use CPUs for local development, and then you can leverage our Node.js GPU enabler to run other calculations functions on a GPU. So, like all things vector, like all things very mathematical, like most things related to AI, GPUs become very important. And having an uh, underpinning architecture that allows you to take advantage of those at scale, um, but also test locally and leverage whatever local GPU your local development system may have. We want you to be able to play with the full spectrum of capabilities and judge where that trade-off is, because obviously, at scale, GPUs, which might be external or have to be loaded into compute units, those are more expensive. So whether or not that trade-off is worth it for you depends on your workload. But we absolutely support them. And you know, the other thing we can do is with our ability to employ other models, so subscription models, token-based models like an OpenAI, we can farm out the embedding generation to an OpenAI that then returns that value for us. So some of that can be offloaded. It's just a matter of where is that cost benefit, and does it matter enough for you?
Okay. Thanks for sharing. I hope that that answers your question, Nick. If you have any follow up, please feel free to ask your follow up between now and the next 12 minutes. Um, I have another question for you actually. When you are doing active replication with CRDTs, how do you handle the edge case where two nodes are simultaneously updating the same vector? And what does conflict resolution look like in a case like that?
So I am updating the exact same field in a record at the
Yeah.
exact same microsecond on
Yeah.
opposite sides of the planet. And
Well, yeah, some different sides of the planet. They might not be opposite sides, but yeah.
fair enough, different sides of the planet, and at the exact same microsecond. So we have a last writer wins. So there is always going to be a timestamp, and then obviously when we are arriving, we are checking version numbers. So the algorithm for deciding which one actually takes precedent is fairly standard in CRDT, and that is comparing version numbers, because this version number, assuming that all things are equal, this, let's say we're both on version one, version two, and version two crossover. This is now version two. Updating this now becomes version two here, but the reconciled version, if I've updated this exact same attribute, is going to be calculated based on some level of tie breaking uh, algorithm, and you can configure exactly how that works. Um, Typically, we can say that uh, we don't very often see down to the microsecond those sorts of conflicts, um, but we do resolve them. I'm going to have to dive more deeply into that answer because I've never seen it happen, but I know that we wouldn't break if we did it. So my
Okay.
apologies for not having that answer off the tip of my tongue.
I mean, that's totally fine. That's totally fine. I have one more question for you then. I mean, we've talked about the logging improvements, and that sounds great for debugging, but being able to see what's happening through every transaction, it sounds like a win, but typically in these kinds of situations, there's a trade off. It's a give or take. So, as much as we're now getting more data, what's the performance overhead here? Are we talking, maybe some kind of query slowdown or something more significant? What is it that you're not telling us?
Uh, the problem we were trying to ameliorate was too many logs. Too many logs coming from every application, irrespective of whether or not they were mission critical, and specifically console logs in an application, which are super helpful for developers when we're creating something, but absolutely unnecessary in a production application. So in all honesty, the HTTP logging allows us to configure exactly what gets logged, so not every attribute, in the form, so not as necessarily as large as it was previously, and on a per application basis. So you may want absolutely every HTTP request for your primary application, but you may not need all of the attributes associated with that application's uh, you know, log entries. So you can reduce that, the shape, and you can ultimately configure it. Now, I I suppose that does mean you could configure it to be more on everything, and ultimately you could overwhelm the logs. And that's what we're really trying to avoid, is writing out absolutely everything is rarely the answer. Shipping them off to a platform that can hold all of that, so that you can analyze it like a Datadog, absolutely. But writing it to disk when you are also using that same disk to persist your mission critical application data, that was what we were trying to avoid. Reducing the write load for our logs to only what is necessary and only for the applications that require it at that depth, and being able to dynamically change that, so that you log less in the instance that you know what's going on, but your challenge is perhaps disk space. So I wouldn't say there's a gotcha. I would say it's all upside. It is more configurable than it ever was, which I suppose on the front end could be a little more work to figure out. But ultimately, we think this is a win-win for everybody.
Okay, this is fantastic. Thank you so much for sticking around with me and answering all my 1 million questions. Shout out to everyone that joined this and stayed till the end as well. Shout out to everyone that typed in the chat with their locations. Shout out to everyone as well that came and had to drop off, or that came in the middle and still stuck to the end. The three main takeaways here are that vector indexing has changed search, and we have it in Harper 4.6, so you should definitely go check that out. Our logging is now more developer focused, and so we are now doing things that aid more developer experience, and performance improvements are free, right? So definitely go check them out as well. Before I round up, Jaxon, do you have anything that you'd like to share with the audience? Any final takes, words, or anything?
I'm just really excited that vector search is now on our roadmap. We have lots of other AI features that we are working on, and we're very excited to see kind of what the future holds for this platform. So as you use it, reach out to us, tell us what works, tell us what doesn't, and let's build the future together.
Okay, fantastic. Thank you so much. We have a bunch of things cooking. We have a bunch of things literally in the oven that we can't wait to share with you. There are a lot of fantastic things that are on the way, and we will share with you when the time comes. But for now, one thing I would like to leave you with is to think about Harper, and if it fits your use case, what part of Harper fits your use case, what you can do with the new updates in 4.6. If you are building real time applications that search and analyze simultaneously, and you're frustrated with maybe multi-system complexity, or you better need you need some kind of better data layer observability, I would definitely say that Harper is worth exploring and you should check it out. At this point, we will end this here. It's been very nice chatting with you today. Thank you so much and enjoy the rest of your day. Have an amazing evening, morning, or afternoon, depending on where you join this from. Thank you.
Thank you.